review. So we first of all talk about angles at a point. We have complementary, supplementary, revolution, and vertical opposite. So if I represent by a graph, so two angles of complementary can be this, two angles. Okay, so in total add up to 90 degrees. I can have angle A and angle B. They will add up to 90 degrees. They are complementary angles. So for supplementary angles, I can have angle A here and angle B here. Those two angles are supplementary angles when they can add up to 180 degrees. Okay, a revolution is angle with 360 degrees. That angle is 360 degrees. Okay, so turn around. Vertical opposite angles. Okay, so I draw two lines and they cross each other. Then the two opposite angles are called vertical opposite. They must be equals to each other. Okay, they must be equals to each other. And then those two are vertical opposite as well. So they are equal to each other as well. Okay, let's talk about angles in from a point. Now let's talk about angles in parallel lines. Okay, if two lines AB and CD are parallel, we write AB parallel to CD. So alternate angles. Okay, alternate angles. I'll show you first with two lines, but they are not parallel to each other. Okay, these are two lines. They are not parallel to each other. And I draw a third line, cross those two lines. Okay, this angle and this angle. Angle A and angle B. Okay, angle A and angle B are alternate angles. But not equal. Okay, I hope you can see what I write here. Alternate angles are not always equal. It just refers to a position. Okay, so those angles are in this position, then they are called alternate angles. So those two angles are alternate angles, but obviously you can see they are not equals to each other. Therefore, we said A and B are alternate angles, but they are not equal. Why they are not equal? Because those two lines are not parallel. Okay, those two lines are not parallel. But if we have this line and this line parallel, okay, they are parallel lines. Then I draw a third line. This angle, say angle C, and this angle, angle C, are alternate angles, but they are equal. Okay, but they are equal. Because it's parallel lines. Okay, if they are in this particular position, then they are alternate angles. But if the lines are parallel, then they are equal. The next one is corresponding angles. Well, again, I'll show you the two lines which are not parallel and the third line cut it. Then this angle and this angle are corresponding angles. Okay, they are corresponding angles. Corresponding angle, I said, is with the F shape. Okay, with the F shape. Why I said it's an F shape, I'll just show you. Oh, that's too big. No. Can you see this? This? That looks like F. Okay, and with the two corner, and that's the corresponding angles. Okay, that's similar to F shape. And this side, I call the alternate as a Z shape. Can you see the Z? Like this is a Z, and with the two corners with angles, they are the alternate angles. So I said this is a Z shape, this is the F shape, and if those two lines are parallel, then those two the corresponding. Okay, I can say those two are corresponding. It's a flip F. Okay, it's a flip F shape. So that's they are equal, okay, because those two lines are parallel. So corresponding angles will be equal to each other if the two linear are parallel, the two lines are parallel. Okay, co-interior angles, they are supplementary if the two lines are parallel. So I will draw two lines. They are not parallel, but this position and this position, A and B, they are co-interior angles. I said this with a C shape. Okay, that's a C shape. So in the C shape, we have angle A and B. They are co-interior angles. Okay, they are co-interior angles. So if two lines are parallel, then we say we have angle C and angle D. Okay, that's angle C, that's angle D. So C plus D should equal to 180 degrees. Okay, they are not equal. Okay, co-interior angle, they will not they will not equal to each other if the lines are parallel, but instead they add up together, they will give 180 degrees. Okay, that's the angles in parallel lines. Well, triangles, angle sum is 180 degrees. Okay, angle sums are 180 degrees. So if I draw a triangle, how to prove it? Like, it's quite interesting to prove it. If I have angle A, B, and C, if I have angle A, B, and C, I want to prove A plus B plus C should equal to 180. What I will do is, I will draw a parallel line at this point, parallel to the base. Okay, that's what I will do. I draw a line which is parallel, okay, parallel to the base. So what I can say is, this angle equals to angle C. This angle equals to angle B, because they are alternate angles. Okay, can you see alternate angles? If I can draw the Z here. Okay, that's one Z. That's the other Z. So alternate angles, and because it's parallel line, so they are equals to each other. So you can see A plus B plus C is a straight line angle, so they add up must be 180 degrees. Okay, the add up must be 180 degrees. So this C is the same as this angle, this B is the same as this angle. So A plus B plus C is actually this straight line angles. That is 180 degrees. Okay, just show you why it's 180. Okay, next one, triangles. Okay, how we can classify triangles? We can classify triangles by two things. The first type I can classify by angles, and the second one I can classify that by lengths. Okay, can be classified by angles. We have acute, obtuse, and right angle. Okay, so right angle triangle, you know that's one angle with 90 degrees. This is right angle triangle. Obtuse triangle, that's one angle is over 90 degrees. Okay, one angle over 90 degrees. Okay, so that can be an obtuse triangle. And that's an obtuse triangle. That's obtuse angle. And acute angle. Acute angle must be all the angle is less than 90. Okay, all the angle is less than 90. Okay, all of it is less than 90 degrees. That will be an acute angle. That's the first group, like classified by angles. I can also name the triangle classified by lengths. I have scalene triangles, isosceles triangles, and equilateral triangles. Well, equilateral triangles is all the lengths are the same. So 3 lengths are the same. Okay, so equal, equal, equal. Therefore, all the angles must be 60 degrees as well. Because all the three sides are the same, then all the angles must be the same. So it's all 60 degrees. Isosceles triangles is with two equal lines. Okay, two equal sides. I can have that. So this angle will be the same as this angle. But I don't know what's the size of the angle now. It's only two angles are the same. Okay, next one is scalene triangle. Is with three different sides. Okay, with three different sides. It can be obtuse, can be obtuse, can be right angle triangle, or it can be acute triangle. So I just need three different sides. Okay, I just need three different sides. Okay, let's guess. I can give a 1, 4. I can have that. I can't have that. For example, I can have that. 2, 5, and 6. 2 add up is greater than the other one. That's fine. So I can have a triangle like that. Okay, so that's triangles. And now let's talk about the quadrilaterals. Okay, quadrilaterals. For quadrilaterals with four sides, okay, with four sides, if I can draw a graph for you, okay, I just draw this here. Okay. Have how many we list here? 1, 2, 3, 4, 5, 6. We have 6 special things this here. We have parallelogram, kite, and others. And the parallelogram, I'll have rectangles. Numbers and I have square. Okay, 1, 2, 3, 4, 5, 6. So the thing I list here. Okay, so I can have this relationship here. Okay, quadrilaterals. I have some special, there are some special names. So the first special type can be parallelogram. Okay, the second type of special things can be cut. Okay, and the third one can be others, but we have the one we list here is trapezium. Okay, we can have trapezium list here. So for parallelogram, what's parallelogram? Parallelogram are with two pairs of parallel lines. Okay, the opposite lengths must be parallel to each other. So we have two pairs of parallel lines. Okay, so rectangles, rhombus, and square, they are all parallelogram. Okay, they all belong to parallelogram, but they are special parallelogram. So why they are special? Why they are parallelograms? Because because rectangle, you know, like there are two lengths parallel to each other. And you know the rhombus, they have 4 equal sides, but they still have parallel side. Square, they have all equals to each other, but they also parallel to each other. So they all rectangle and rhombus, they are the special type of parallelogram, and square is the special type for rectangle and rhombus. Okay, so if we can sketch that, parallelogram looks like this. And then rectangle is parallelogram but with right angle. Okay, right angle, 4 right angles. And rhombus is parallelogram but with 4 equal sides. It's exactly the same as a parallelogram but with 4 equal sides. And square is a special rhombus and is also a special rectangle because the 4 sides are equal and also we have 4 right angles. So square is a special thing. Okay, it's a special of those two, and it's also a parallelogram. So that's a square with 4 sides equal. Okay, rhombus is 4 sides equal. And for a kite, kite is the adjacent lengths are the same. Okay, that can be a kite. You know, like what kite looks like? It's the 2 adjacent lengths, 2 pairs of equal adjacent lengths. So 2 short ones, 2 longer ones, that's the kite. Okay, last one is trapezium. Trapezium is with 1 pair of parallel line only. Okay, 1 pair of parallel line only, and the parallel line must be opposite to each other. So only, I can't have 2 pairs of parallel lines. I can only have 1 pair of parallel lines. So, okay, and they are not the same side. Okay, they are parallel lines, right? Those 2 are parallel lines. And I can connect the other side. Okay, that's a trapezium. Or I can do this. They are parallel to each other. The other 2 not. That can be a trapezium. So with 1 pair of parallel lines only. Okay, so that's the shape. That's all the different shapes we have for quadrilateral, the special ones. Okay, so you can use this chart to remember them. Okay, now we have talked about triangles with 3 sides, and we have talked about quadrilaterals with 4 sides. Now we start to talk about things with more sides. Can have 5, 6, 7. So the name, well, you don't really need to name more than this. So 3 is triangles, and 4 is quadrilateral, 5 is called pentagon, and after 5 is not special anymore. 6 is called hexagon, 7 called pentagon, and octagon, nonagon, and decagon. So it's all with G-O-N. So it's called polygons. Okay, it's polygons. So with more side. Okay, with more side. Now this formula, I think you will definitely have that in your test. Okay, you will definitely have that in your test. I'm not writing this test, but I think this will definitely be tested. So the sum of polygons, the inner angle sum of polygons. Okay, inner angle sum for polygons. Okay, so let's do something interesting. So we have triangles. Okay, we have triangles. We have quadrilaterals, and we can have pentagon. And we said we have hexagon. Let's do up to pentagon. Okay, so 7, 1, 2, 3, 4, 5. 3, 4, 5, 6, 7 lengths. Then I want to think about number of triangles I can make in each shape. Okay, for example, I draw a triangle. How many triangles are there in this triangle? 1. Okay, 1 triangle. There's only 1 triangle. But if I think about the quadrilateral, like any four-side thing, like it's not going to be special. Just randomly sketch something. And I draw, okay, I start from one point to cut this into triangles. I cut like this. So how many triangles you have seen? 2. Good. 2. Okay. Pentagon, like with 5 sides. Okay, think about how many triangles you can make here. 3. I can start from this point. Cut here. That's 3 triangles. Okay, let's do last one. Okay, draw a hexagon. How many triangles you can make? Let's count. If I choose this point to cut, so I can cut here, here, and here. Okay, 1, 2, 3, 4. 4 triangles. So let's predict how many triangles can you make for a pentagon. 5. Good. 5. Okay, triangles is with 3 sides. Quadrilateral is with 4 sides. Pentagon with 5 sides. Hexagon with 6 sides. And pentagon with 7 sides. Okay, if I go dot, dot, dot. If I have 98 sides, how many triangles can you make? 96. So it's 98 minus 2, right? So it's reduced by 2. Like how many triangles you can make is the total number of sides minus 2. That's how many triangles you can make. Because I'm talking about the inner angle sum. Okay, let's look at this hexagon. All the inner angle sum will be those angles, these ones, and also these ones. So it's actually every 3 dots sum will be 180 degrees because it's within one triangle. So how many triangles you can make times 180, that will be the inner angle sum. So therefore, this formula is easy to understand. The sum will be n minus 2 is how many triangles you can make from that shape, and times 180 is the inner angle sum. So this gives you how many triangles. So it's how many triangles. Okay, this formula you must remember because that will definitely, you have this in either multiple choice or short answer question. It's very important. Okay, now the next definition is we have regular polygons. What are regular polygons? Regular polygons have equal sides and equal angles. For example, this is not a regular polygon because all the sides are different, all the angles are different. Number 3 is, the 3 is not a regular pentagon because different side angles different. Number 4, like the hexagon, can be a regular hexagon because you can see all the angles are approximately the same and the lengths are approximately the same. So that's a regular that can be a regular. If like it's an equilateral triangle, then it's a regular polygon. So when it's a regular polygon, okay, you will have n sides, and then you will have n angles. Because how many sides? If you have n sides, you will have n angles, and you can find the total angle sum equals to 180 times n minus 2. That's the total angle in the angle sum. So each angle equals to 180 times n minus 2 over n. Because it's regular shape, it must be regular. If it's not regular, you can't use this formula. But if it's regular, then I use the total number of sums divide by the number, how many angles we have, and that will give you each angle. Okay, each angle equals to the total divide by how many angles you have. Okay, next one. Exterior angle theorem. Okay, exterior angle. So it's talk about the triangle. Okay. So if I have angle A, B, C, and this angle D is the exterior angle of angle C. Okay, the outside angle. So D will equals to A plus B. Okay, so the exterior angle is equals to the sum of the two opposite interior angle. Okay, so the outside equals to the add of those two. Okay, the D equals to A plus B. So if I have another exterior angle, for example, this side, if I say that's an X will equals to A plus C. Okay, this X will be A plus C. The other opposite, okay, the other two opposite one is not the one in next to the X, it will be the outside two. So that's the exterior angle theorem. Okay, I'll just do one question with you and you can do the rest of that. I'll do example 3 with you. Well, I'll tell you example 1, you need to add a line here. Okay, add a parallel line. You need to draw a parallel line parallel to AB and DE. Then you can work out the rest. Okay, let's have a look at this. Find the value of the polynomial x. Okay, find the angle for the polynomial x. So let's have a look. We have this shape here is a quadrilateral with 4 sides. If you ignore that one, that's with 4 sides. That's a quadrilateral. Can you tell me in terms of x, what's the size of this angle? What's the size of this angle in terms of x? 180 minus bracket x plus 100. Thank you. And we can calculate that. And that gives us 80 minus x. Okay, so we have this angle here is 80 minus x degrees. Okay, now we have all the 4 angles in the angle. 1, 2, 3, 4. What's the interior angle sum for quadrilateral? 360 degrees. Good. It's same as a rectangle. Okay, if you know quadrilateral is a rectangle, 4 angle add up is 360. So I will have 120 plus 90 plus 2x plus 55 plus 80 minus x. That equals to 360 degrees. Okay, angle 1, angle 2, angle 3, and angle 4 add up together. That gives you 360 degrees. So what I have here is 210 plus, okay, add those two together, 135 plus x, 2x minus x is x, have 360 degrees. 345 plus x equals to 360 degrees. X is 360 minus 345 is 15 degrees. Okay, so that's for this question. The rest of that will work with a similar working here. The next one, I'll just have a look at the next one. How many lengths are there for the next one? What polygon is that one? Have 1, 2, 3, 4, 5, 6. So that's a hexagon. Okay, that's a hexagon. What's the inner angle sum for this hexagon? 180 times 6 minus 2. Good. So it's 180 times 4. 720. So the inner angle sum is 720, and you can do adding them together and solve for them. Okay. And also remember there's a parallel lines. Okay, also remember there's a parallel lines. You should draw a parallel line here. They give you a hint. You should draw a parallel line here to work out the value of b first, and then do the rest. Okay, that's a hint for you. You can try to think about that later after I finish. Alright. Now I have to do a little bit revise on congruent triangles. So what are congruent triangles? Congruent triangles are triangles looks identical. They are exactly the same. They have exactly same side, exactly same angles. So in each triangle, you have 3 sides and 3 angles. So there are 6 things in total. Okay, 6 things in one triangle. But you're not going to say, okay, I give you one triangle A here and triangle B here, and I want to ask you, are they identical? Are they congruent triangles? You're not going to test, okay, length 1 equals to length 1, length 2 equals to length 2, length 3 equals to length 3, and then angle 1 same as angle 1, angle 2 same as angle 2. Like, it takes too long, okay? I don't need to test all of these 6 conditions to make the conclusion they are congruent or not. So instead, I just need to look at 3 things. Then I can confirm they are whether congruent or not congruent. So what are the conditions I can use? There are 3 things I can look at. And also there are 4 groups of those 3 things I can look at. The first group I can look at is all the sides. If all the sides are equals to each other, side, 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 if all the sides are already the same. So for example, I give you a triangle. That and that. I said that's 1, that's 1, that's 2, that's 1, that's 2, that's 3, that's 4. I said that, and I said that's 2, that's 4, that's 3. You can see, okay, 3 numbers, they are the same. I don't care about the angles anymore because the angle must be the same. Okay, the angle must be the same. So they are congruent. I don't need extra information for angles if I already have 3 sides. I can make the congruent. Yes, they are congruent. Okay, the next one I want to talk about is SAS. If I know 2 sides are the same, if I can say, okay, this side is the same as this one, side 2 is the same as the side 2. Now I need an extra information. If I don't have the third one, then I need a piece of information for the angle. Okay, for the angle. But this angle is a special angle. This angle must be included in the 2 sides. If it's not included in the 2 sides, I can't make the conclusion. Give you a wrong example. If you have 1 and wrong way, 3 and 2 here. Like this. Well, I know it doesn't look like 3 and 2, but it's alright. Now okay, 2 pieces of information. 2 sides are the same already. Now I want a piece of information for angle. Well, you can see they have 2 angles are the same, right? But can you say they are congruent? Are they congruent triangles? Is it satisfy the condition? What this A I said? This A must be where? In between the 2 sides. So yes, I give you angle equal, but it can't be any random angle like they are equal. So it must be the angle included in this. So I'm not sure whether they are congruent or not, but I can't make the conclusion. Okay, I can't make the conclusion. They might be the same. Who knows what the other angle looks like? It might be the same, but I can't 100% sure say it must be congruent because the angle is not included. Okay, it's not included. It must be inside. So a good example will be that 2 angles must be congruent. Okay, that 2 angles must be congruent. The triangles must be congruent because they have 3 and 4, 3 and 4, they are the same, and the angle is inside. Okay, it's in between the 2 lengths. Then they are congruent. And this one, yes, congruent triangles.
Wait, what do you mean inside? The angle is between 2 lengths, so the 2 sides?
The 2 given lengths.
Then that angle. Oh.
It can't be any other 2 angles that equal. Like even though the equal doesn't mean anything, it must be an angle in between the given lengths.
Yeah.
Okay, that's the second one. You can say whether they are congruent or not. And the third one we have. Okay, the third one is much easier. This one is AAS or ASA. Okay. AAS means you have angle and any side. Or you have angle and angle, the side is in between 2 angles. But like overall, I said this one is we have 2 angle and any side. If I can have 2 angles equal and any side equal, then we can say it's congruent. But you must remember a word. Corresponding. Okay, corresponding. I will draw an example for you and you tell me whether they are congruent or not. Those triangles are congruent triangles. Why not? Which one is not corresponding? Okay, if I ask you to change this angle, something in this angle, what you will change and to make it congruent? You change it to the other spot. Yeah, that will make it become congruent. Okay, why is not congruent? It's like two angles equal, two sides equal. But the problem is this 5 is opposite to this nothing. Okay, this nothing angle. But this 5 is opposite to the 16. The 5 is not at the correct place. If you talk about the side must opposite to the same angle. Okay, the side must opposite to the same angle. So if I can change my 5 to here, then they are corresponding. Okay, so it's opposite to this nothing angle, or you can change it 60 degrees, that's the same thing. So two angles, okay, so first of all, two angles, they equal already. Now I will look at the side. Is that the side at the right spot or not? Even though they are equal, but they might not be corresponding lengths. So now they are corresponding because they're all opposite to the same angle. Okay, they're all opposite to the same angle. So then they are corresponding. Otherwise, the previous case is not corresponding lengths. Okay, that's the third one. And the fourth one, I think the book called this HL, and I like to call it RHL because everything needs 3 conditions. Okay, everything needs 3 conditions. I like to call that a RHL. What's RHL? R represent right angle. Okay, R represent right angle. What H represent? That's hypotenuse. And what's L represent? The straight side. Okay, the shorter straight side, like any straight side. I should say any corresponding straight side. Yes?
Is RHL just the same as side angle side?
Side angle side. It's a little bit different. I'll show you the difference. Okay, this is similar. Well, I'll show you 2 right angle. Okay, I'll show you 2 right angle triangle. For example, this one. Okay, it's a right angle triangle, and this one is right angle triangle. And if I said like it's 90 degrees, 90 degrees, that's information for angle. And if I said that length is 3, that length is 4, that length is 3, that length is 4, they are congruent, right? They are congruent. They are congruent, this one because of SAS. Because we have 2 sides and the included angle. So that's the SAS case. But RHL is a little bit different from this because it needs hypotenuse and any straight side. So this case I should have right angle here, right angle here. I should say hypotenuse is 5. Hypotenuse is 5, but here is 3. Here is 3. So you can see this is 2 side given. Yes, 2 side given. But the angle is not the included angle. Okay, the given angle is not the included angle. The equal angle is outside, which normally shouldn't work, but in right angle triangle it works. So this one is a special one, which called RHL or HL. So it's right angle, hypotenuse, and length. Okay, right angle, hypotenuse, and length. this one is not the included angle, but it can work because it's a special, it's right angle. The right angle is one additional information we have. Okay, there are only 4 cases we can test that, whether they are congruent or not. 3 SSS, we have SAS, the A must be included. And the similar one can have RHL, which is the right angle case, which the angle is not included but still work because it's right angle. And the last case is AAS, or okay, when I say AAS, I can say it's actually AAAS. Do you agree with that? I said AAS, but it's actually AAAS because if 2 angles are the same, then the third one must be the same already. So I actually know 3 pieces of information for angles already, but only say angle is not enough. The side also needs to, at least one side needs to be the same. So it's an AAAS case. But like we say in 3 things, like AAS. And the S can be anywhere. Okay, SAA or ASA or AAS, they are the same. Okay, for example 1, can you tell me why they are congruent? I will tell you they are all congruent triangles, but can you tell me why they are congruent? Which rule? Like 1, 2, 3, 4, which rule? First one, RHS. Okay, we have right angle, we have hypotenuse is the same, and we have one straight line is the same. So it's RHS. Okay, another thing I want to tell you is we are quite strictly on how to write the statement. You know, like ADC and ABC, they are congruent triangles. But when we write the 2 triangles, we need to write things in particular order. Like the corresponding point must be at the correct place. So for example, for this one, I can write triangle ABC. Okay, I write ABC already. So congruent, the 3 lengths means congruent. That means congruent triangles, so they are equivalent is given here. Okay, it's given here. It's congruent. Okay, congruent to triangle ACD or ADC depends on how we write it, but we need to write it ADC. I can't write ACD because B and D, they are corresponding pairs. A and A, they are corresponding. C and C, they are corresponding. Because can you see B and D, they have all right angles. And that's the corresponding point. And A share the same angle, then A will be corresponding point. So instead of writing ACD, you must write ADC. So write things in corresponding order. Okay, if you think about next one, what's next one? Why next one congruent to each other? Because of which one? AAS or ASA. Doesn't really matter, they are the same. AAS or ASA. Well, in this case will be an ASA case because it's A, and the S is in between. Okay, the S is in between, like in between the 2 A. So I will say ASA for this case. Or AS doesn't really wrong, like you can say AS as well. Okay, now how we write it. Like I will write the first one. I will say triangle ABD. Congruent to triangle what? Okay, can anyone tell me the order? BCD or DBC or DCB? Or BCD, like which order? C, B, D. Okay, that's correct. Can you see A is corresponding to the C? So A is the same angle with the C. And B is here. Wait. B, okay. B is this angle. So now it's corresponding to this angle here. So it's D first and then B. Okay, so it's C, D, B. Because when I write D in the first one, this D is this cross, and then is the B in the next one. So it's C, D, B. You look at angles. Which angle are the same? Which angle are equals to each other? Then you write in that order. Okay, for this one, why they are congruent? AS, SAS, SSS, RHS, which one? SSS. Because they are all equals to each other, because this is the radius. Okay? They are isosceles triangles, but they also congruent triangles. They all equals to each other, so it's SSS case. Okay, if I write triangle AOB, congruent to triangle, okay, what do you write for the next one? AOB. I heard that. Who said that? What's that? COD, or DOC will be the same because the angle are actually equals to each other. So COD. Okay, so COD. So this angle are the same as this one. So it's AOB and COD. Alright, the next one is easy. Do the same thing for the next one. I'm not going to do the next one with you. Next lesson we'll go through proof. Okay, go through some proofs. But before that, you need to remember all these rules, those 4 rules. Okay, SSS, AS, or AS, or SAS, or RHS. Okay, remember those rules. And you can complete the exercise before 2B. Okay, before 2B.